Have you ever stopped to wonder how a printer can actually build a real object? Not just words on paper, not just images, but something you can touch, use, and hold in your hands. Imagine watching a machine slowly draw thin lines, one on top of the other, until suddenly an entire tool, a toy, or even a piece of medical equipment appears right in front of you. It feels like magic, but it is not magic. It is engineering, science, and imagination working together. This is 3D printing, and today we are going to explore how it turns digital ideas into physical objects, why it matters, and how it could change your life in ways you do not expect. Stay with me until the end, because what starts as a curiosity could reshape the world around us. The first thing you need to understand is that 3D printing flips the traditional way of making things upside down. In the past, if you wanted to create something, you usually started with a block of material and carved away until you got the shape you wanted. Think of a sculptor chiseling marble, or a machinist cutting metal. That is called subtractive manufacturing, because you subtract material until the object emerges. 3D printing does the opposite. Instead of cutting, it builds. It adds material, one layer at a time, until the object is complete. That is why the technical name for this process is additive manufacturing. Now, let's picture it happening. You design a coffee mug on your computer. That digital model is sliced by software into hundreds or thousands of thin layers. Each slice is like a cross-section of the mug. The printer then starts at the bottom. A nozzle or laser or light source places the first layer, paper thin. Then another layer is added on top. Then another. Slowly, the mug rises from nothing. When the process is finished, you are holding in your hands a real mug that started as nothing but digital information. It is like watching a thought become reality. But how does the printer know what to do? This is where the software takes control. A program called a slicer translates the 3D model into precise instructions for the machine. These instructions tell the printer exactly where to move, how fast, when to extrude material, and how thick each layer should be. The printer follows these commands step by step. Without the slicer, the machine would be clueless. It is like giving directions to a chef. Without the recipe, the chef knows how to cook, but not what dish to make. The slicer is the recipe for turning your design into reality. What about the materials? Many people imagine 3D printers only use plastic. And yes, plastic is common, especially in home printers. A spool of filament is fed into a heated nozzle, melted, and deposited onto the print bed. But the story does not end there. In industry, printers can use metal powders fused with lasers, resins hardened by ultraviolet light, even concrete extruded to build walls. Scientists are even experimenting with biological materials, printing cells that could one day form tissues and organs. Each material requires different methods, but the principle remains the same. Add layer after layer until the object is complete. There are different technologies. One is fused deposition modeling, where melted plastic filament is drawn out line by line. Another is stereolithography, which uses a laser to harden liquid resin, producing prints with very fine detail. Then there is selective laser sintering, which uses a laser to fuse powdered material into solid form. Each method has strengths. Filament printers are affordable and versatile. Resin printers produce smoother surfaces. Powder-based printers can handle metals and industrial applications. But all follow the same additive approach. Let's look at a real story. In 2012, engineers produced a critical engine part for an aircraft using 3D printing. Traditionally, that part would have required multiple pieces welded together. With printing, it was made in one piece, lighter, stronger, and cheaper. That part flew in real airplanes, showing that 3D printing was not just for prototypes or toys. It could handle serious applications. Stories like this reveal how powerful the technology already is. But if 3D printing is so powerful, why don't we use it for everything? The answer is scale. Factories with traditional machines can produce thousands of identical items quickly. 3D printing is slower for mass production, but its strength is flexibility. It can make complex shapes with the same ease as simple ones. Complexity comes for free. Imagine printing a lattice structure with curves, hollows, and fine details. Traditional methods would struggle. For a printer, it is just more layers. That makes it perfect for custom work, prototypes, and complex designs. Take medicine. A surgeon can scan a patient's bone and print an implant that fits perfectly. Dentists can print crowns and braces tailored to each mouth. Prosthetic limbs can be designed quickly and cheaply, giving patients affordable solutions. These are not dreams. They are already happening. 3D printing brings personalization to manufacturing in a way no other method has before. How strong are these objects? That depends on the material and the method. Some are fragile, especially cheap plastic prints. Others, made with advanced composites or metals, are extremely durable. Technology keeps improving. New filaments with carbon fiber or nylon are much tougher than basic plastics. Metal prints can be as strong as parts made by casting or machining. What once was fragile novelty is now becoming robust reality, and the applications keep expanding. In space, astronauts have already printed tools on the International Space Station. Imagine something breaking in orbit. Instead of waiting months for a replacement from Earth, they just print one. For missions to Mars, this could be the difference between success and failure. On Earth, construction companies are experimenting with massive printers that extrude concrete to build houses in hours. Affordable housing projects in developing countries have already used this method. Imagine printing entire neighborhoods quickly and cheaply. That could change how we tackle housing shortages worldwide. Food is another surprising frontier. Some experimental printers use chocolate, dough, or other edible pastes to create dishes. Fancy restaurants have printed desserts that look like works of art. While not mainstream yet, it shows how versatile the concept is. If we can print food, structures, tools, and even medical implants, the possibilities feel endless. But we also need to consider challenges. Speed is one. Cost of industrial machines is another. Intellectual property questions arise when designs can be shared and printed by anyone. And ethical concerns appear when the technology is used to create controversial items like weapons. Like any powerful tool, 3D printing can be used for both positive and negative purposes. The responsibility lies in how society manages it. For everyday people, the impact is already visible. Hobbyists print toys, models, and replacement parts at home. Communities share designs online, so anyone can download a file and bring it to life on their own printer. Break a refrigerator handle? Print a new one in a few hours? Need a custom phone holder? Print it instead of buying it. This is manufacturing in the hands of individuals. It is a shift in how we think about production and ownership. Let's step back and look at the big picture. Why is 3D printing so revolutionary? Because it makes imagination physical. In the past, there was always a gap between an idea and a real object. That gap required factories, tools, and complex supply chains. 3D printing narrows that gap. It allows a person to think of something, design it digitally, and hold it hours later. That is transformative. It is like having a personal factory on your desk. Think about education. Students learning engineering can design and print prototypes, testing their ideas immediately. Artists can experiment with new forms impossible to sculpt by hand. Scientists can create custom lab equipment on demand. Every field gains new possibilities when ideas can move so quickly from mind to matter. The future holds even more. Printers could become faster, cheaper, and capable of handling more materials. They might integrate with artificial intelligence, automatically generating designs optimized for strength, weight, and function. Entire supply chains could shift, with products made locally instead of shipped across oceans. Imagine a world where instead of buying many things, you simply download the design and print them at home. That would change economies, industries, and daily life. So let's return to the core question. How does 3D printing create real objects? By stacking material layer by layer, guided by digital instructions until an idea becomes tangible. It is a process that feels magical, but is grounded in physics, chemistry, and engineering. It is a bridge between the digital and the physical, between imagination and reality. And it is still only at the beginning of its journey. Now I want to turn the question to you. Did you know how 3D printing actually worked before this? Can you imagine a future where printers are as common in homes as microwaves or laptops? Would you like to print your own tools, clothes, or even meals someday? Share your thoughts in the comments, because your perspective adds to this conversation. And if this exploration opened your eyes to how powerful 3D printing can be, hit the like button, share this video with friends, and subscribe to the channel. That way, you won't miss the next deep dive into the technologies and curiosities shaping our world.